us start with a very important derivation, that is analytical treatment of interference. For this treatment, you need to understand one very important diagram here. So let us start. Now, we are going to consider two sources which are going to be covalent. The name of these two sources are S1 and S2, and they are placed at a distance small d from each other. Now, these sources would be creating a pattern which would be visible on the screen, which is kept at a distance capital D from the source. And guys, now let us do some construction. I'm going to make OP which is perpendicular to the plane of screen, and you are going to consider a point Q on the screen which is placed at a distance x from P. But guys, keep one thing in mind: small x is very small. Getting it? It's going to be small as compared to the distance of the screen and the source, that is capital D. And just one more construction here. You are going to draw two perpendiculars, that is starting from S1 and S2, and they would be named as M and N, having bisecting. Basically, we can say these are going to bisect S1, S2 in D by 2 and D by 2. So guys, this is what is basically the construction for diagram is. Now, you can easily see the path difference for these two light waves would be simply S2Q minus S1Q, right? And we need to find out what is the path difference basically. So let us carry forward. So this is our diagram. We can see there are two triangles, and out of these two triangles, let me consider triangle S2Q and N. In this triangle, basically I'm going to apply Pythagoras theorem, and according to Pythagoras theorem, hypotenuse square is equal to one side square plus the other side square. So it looks like S2Q square is equal to S2N square plus QN square. And guys, from the diagram we can obtain values for this. I can say S2N is nothing but capital D, and I can also say QN is nothing but x plus D by 2, because x to P is x and P to N is D by 2. So it would be x plus D by 2. Substituting this value here, you can get like it's D square plus x plus D the whole square. Similarly, in the above triangle, that is triangle S1QM, we can apply the same Pythagoras rule here, but we would get what? S1Q square is equal to S1M square plus QM square. And you can substitute the values of S1M and QM here, and you'd get S1M as D and QM as x minus D by 2, because QM is shorter than QP. QP is having distance x, but you need subtract x minus D by 2. You get exactly what QM is. So I'm going to substitute these values here. Now we have two values. One is S2Q square, the other one is S1Q square. Give it as equation. Now we are going to consider these two equations for next steps. What I want is, I want to subtract these two equations, because part difference means subtraction. I'm going to subtract it. On subtracting LHS, it looks like S2Q square minus S1Q square, and on RHS it becomes like D square plus x plus D by 2 the whole square minus D square minus x minus D by 2 the whole square. D square would get cancelled. This looks like an expansion formula: a plus b the whole square and a minus b the whole square. So on expanding, it would look like x square plus 2x d by 2 plus d by 2 the whole square. And for the next term, it would be like x square minus 2x d by 2 plus d by 2 the whole square. On getting the minus sign inside the bracket, this term would get a bit simplified, and it would take this format. where we can see x square and x square would get cancelled, d square by 4 and minus d square by 4 would get cancelled. So the remaining terms are xd plus xd, that is 2xd. So what I have obtained here? I have obtained s2q square minus s1q square as equal to 2xd. This is nothing but a square minus b square, that is a plus b and a minus b. So I can write this thing as s2q plus s1q, s2q minus s1q, which is nothing but equal to 2xd. But we know something here. Yes, we know that capital D is very less than x, and s2q and s1q carry same value, that is d. We can substitute it there, it would become d plus d. And s2q minus s1q is nothing but what? It is path difference. So substitute all these values here, guys. What would be the derivation? It's 2d into path difference equals to 2xd. The 2 would get cancelled. In short, I would get path difference of any point as xd upon capital D. So this is analytical treatment, guys. We have obtained an expression for path difference. Thank you.